Hello students, welcome back to Rankers. Today in this session we will be discussing about the interior structure of the Earth. If we see the recent trends of the exam, see in the examination geography started playing a very major role, right? You take any of the exams, you take the state level exams, you take UPSC, you take SSC, you take any standard of the exams, geography started playing the major role, and in the geography the most important topic will be physical geography, because physical geography consists of all the concepts, right? How Earth was formed, what is Earth, why is Earth, how is Earth, right? All the physical concepts of the geography will be in the physical geography. In this physical geography, this part plays a very major role. What is this part? This part is interior structure of the Earth. Interior structure of the Earth means what does Earth consist inside the surface, right? Before going to the subject, see we will be calling Earth as a biosphere. What will be calling Earth as a biosphere. So what is a biosphere? See, biosphere is something where the life exists, right? What is biosphere? Biosphere is something where the life exists. That means the Earth consists of 3 layers. How many layers Earth consists of? Earth consists of 3 layers. What are the 3 layers? One will be atmosphere, second will be lithosphere, and third will be hydrosphere. Right? So what are the 3 layers of the Earth? One will be atmosphere, lithosphere and hydrosphere. Atmosphere means the complete gases and air on the Earth will be called as atmosphere. The complete solid part will be called as a lithosphere. The complete water part will be called as a hydrosphere. Right? Means see, Earth is having 3 layers, but on these 3 layers, where is the life existing, right? See, we cannot say that complete life exists all over the sky. That means if we see the sky is a very long distance. It is having nearly 3,600 kilometers. In this 3,600 kilometers, we cannot say complete life exists, right? At the same time, what is the diameter of the Earth? The diameter of the Earth is nearly 12,000 kilometers. In this 12,000 kilometers, complete 12,000 kilometers, there are no life. At the same time, if you see hydrosphere, that is oceans, the depth of the oceans will be some 5 to 8 kilometers. In this 5 to 8 kilometers, only near the beaches or the way the ocean meets with the land, there only we can see the life. That means what is biosphere? Biosphere is the area where 3 layers. Biosphere is the area where 3 layers intervene. That means if we write biosphere as a Venn diagram, in the Venn diagram we will be calling this as atmosphere, we will be calling this as lithosphere, and we will be calling this as hydrosphere. It is what is biosphere? Biosphere is the area where 3 layers interfere. That means the interfering area of 3, that is atmosphere, lithosphere and hydrosphere, will be called as biosphere. That means life exists only on a very minimum part of the Earth. That means in the complete Earth we are not having the life. In this, on the lithosphere, where there is life on the lithosphere, for example, if we take this as the interior, this as the block of the Earth, on the Earth where is the life? Life is present only on the surface of the Earth. Right? Beyond the surface of the Earth we are not having the life, and above the surface of the Earth we are not having the life. So today what is our session? Our session is what exactly is there? What exactly is there inside the Earth? Because if we see the recent trends, in the recent trends there was a question. What is the question? What is the discontinuity between crust and mantle, right? Because interior structure of the Earth will be having 3 layers, that is crust, mantle and core. So what they have asked? They have asked the discontinuity between crust and mantle. But in the other exam, in the SSC exam, they asked the discontinuity between upper crust and the lower crust. That means in the interior structure of the Earth, which is the most important topic, the discontinuity and the interior structure of the Earth is very important. But what is the other question? Other question is, why Earth is having 7 continents, or else why complete Earth is having 7 continents? Why continents are moving, right? This question will be linked to Himalayas, right? How I can link this question to Himalayas? See, again there is a question on Himalayas. What is the highest peak on the Earth? Highest peak on the Earth will be the highest peak of the Earth will be Mount Everest. What is Mount Everest? Mount Everest is the highest point on the Earth, and the height of Mount Everest is presently it is 8852 meters. That means 8.8 kilometers. But if we see the height of Mount Everest when we are childhood before the 15 to 20 years, see the height of the Mount Everest was 8848 meters. See, when I was reading this 6th to 7th class, that at that time the height of Mount Everest was 8848 meters. But now height of Mount Everest is 8852 meters. how height of Mount Everest has been increased. See, most of the theories will be giving ice cap was increased, that was increased, this was increased. But what we are saying, the original height of Mount Everest has been increased. How the original height of Mount Everest has been increased? That means, see, India, like for example, we are calling this as an India. See, India is two plates. One is Indian plate. Second one will be Eurasian plate. India is moving inside the Eurasian plate, right? That means here we are having a plate like this, and India starts. I'm taking a 2D diagram. India is coming like this, right? When India is pushing the plate like this, what is happening here? Here India has been rising like this, right? This rising parts will be called as Himalayas. See, whenever India is moving, the Himalayas starts increasing the height. That means this plate is having movement like this, right? So up to when this plate will be moving, when the complete India will be going inside the Eurasian plate. That means there will be one day where we will be not having any land in the ocean. That means we will be not having this part of India, because this part of India will be going completely into the Eurasian. So what is the point here? Whole point here is land is moving. What is the whole point? Land is moving. Why land is moving? Why land is moving? Because our complete crust is floating on a liquid part. That liquid part will be called as Asthenosphere. Due to the liquid part of Asthenosphere, our Earth is completely divided into 7 major plates, and these major plates will be moving, right? But that means below the Earth plate, we are having liquid, and these plates are moving freely on the liquid, just like a rafts moving on swimming pool, right? In a swimming pool, if you throw 7 rafts, what is raft means? A plank of a wood or something. If you throw the 7 rafts in the swimming pool, what will happen? These rafts will be moving in a different manner. Some rafts will be coming together, some rafts will be going from away, some rafts will be sliding. In the same way, the 7 plates are sliding over Asthenosphere. This is recent discovery, right? So there are many questions on the Asthenosphere, and this theory will be called as plate tectonics theory. How the question will be asked? How the question will be asked means, why there are more earthquakes on Japan? Why there are more earthquakes on Japan? Why there are more earthquakes on Japan? Because always Japan will be in the news on the earthquakes or tsunamis, because Japan is famous for earthquake as well as tsunami. Why there are more earthquakes and tsunamis in Japan? Because this is Japan. Japan is on the border of 2 plates. So when it is on the border of 2 plates, this plates may come together, this plates go away from each other, this plates may slide on each other, right? That is why Japan will be having always an earthquake and always an tsunami, other things, right? But that means complete plate tectonics is dependent on Asthenosphere, and Asthenosphere is one of the layer inside the Earth. So in the recent examination trend, this interior structure of the Earth played a major role, right? Let us see very briefly in this session how is an interior structure of the Earth has been developed, right? So please remember, most of the important questions of geography are coming from the interior structure of the Earth. How interior structure of the Earth has been developed. Let us see how interior structure of the Earth has been developed, right? See, everyone know the shape of the Earth is, see, the general condition of the Earth will be writing as the shape of the Earth will be sphere, but the original shape of the Earth is not sphere. The original shape of the Earth is geode. What is a geode? Geode means if you take a smiley ball, like we will be having something called a stress ball, let's say a sponge ball. Press the sponge ball from top to bottom, right? If you press the sponge ball from top to bottom, the top surface and the bottom surface will be submerged and the edges will be bulging. That means ball will be flat on the tops and bulges will be on the edges. That is the shape of the Earth, and the shape of the Earth will be geode. For our general understanding, we will take Earth as a sphere. Now, if I take Earth as a sphere, to study the internal part of the Earth, I will cut a cone like this. To the center of the Earth, I will cut a cone like this, and I will take the cone. When I will take the cone, I will draw the cone here. Now we are drawing the cone. That means I have taken a very big piece of Earth like this. This will be the center of the Earth. Below we will be having the other cone, right? Now, if we take like this, so how many structures are there? Here there will be the first layer, which will be called as crust. Here we will be having second layer, which will be called as mantle, and mantle is the largest layer. Here we will be having third layer, which will be called as core. So how many layers we are having? We are having 3 layers: crust, mantle, and core. And the topmost surface of the crust will be called as, topmost layer of the crust will be called as surface of the So where is surface of the earth? Surface of the earth is present on the crust, right? Now, so how many layers are having? Crust, mantle, core, and these three layers are having three different compositions. What are the three different compositions? Why we are differentiating a layer? We are differentiating a layer because three layers are having different composition, because their physical properties are completely different. On the brief, we can say that crust consists of Cl, mantle consists of Sema, and core consists of knife. So what is Cl, Sema and knife? Cl means silica plus aluminium, Sema means silicon plus manganese, and knife means nickel plus ferrous, right? Now this is the interior structure of the earth. Now, so again crust will be divided into two. Before going to the division of the crust, see, when we send the earthquakes waves like this, for example, if this is the head, and we'll take this as USA and we'll be taking this as China, because China will be right opposite of the USA. That means if you drill a hole in China, if you drill a big hole in China, that hole will be ending up in USA. That means we can have a hole from China to USA, because China is perfectly opposite of this USA, right? See, if I develop earthquake waves here in China, if I develop the earthquake waves, these waves will be coming like this, and some waves will be going like this, and some waves will be going like this. Now, because these blue color waves are called as S waves and red color waves are called as P waves. In the earthquake, we are having two types of waves. One is P wave and second one is S wave. P wave can travel in solid as well as liquid, but S wave will be only traveling in solid. That means S wave is not traveling from the liquid and S wave is diverted. By this we can say that there is some liquid in the center. We will come to this part in the later class, but now we are discussing about the division between crust, mantle and core. So when we see the properties, see the intensity of P wave is at a particular intensity to some extent. After some extent it is becoming uniform. Again for some extent it is increasing. Again it is becoming uniform. Again it is increasing. That means now if I take like this is going like this. Intensity will be uniform, again rising, intensity will be uniform, again it is rising. See where it is uniform? It is uniform because there is nothing is happening, neither increase in the intensity, neither increase in the density. That means that area will be called as discontinuity. And what is discontinuity? Discontinuity is a border of two layers. What is discontinuity? Discontinuity is a border of two layers. Crust will be having discontinuity with mantle, and mantle will be having discontinuity with core. The first discontinuity will be called as Mohorovičić discontinuity. The first discontinuity will be called as Mohorovičić discontinuity, and second discontinuity will be called as Gutenberg discontinuity. So initially how many discontinuities we are having? We are having three layers and two discontinuities. First discontinuity will be Mohorovičić, second will be Gutenberg, right? It is obvious that if we are having three layers, how many discontinuities will be having? We'll be having two discontinuities, right? But if we go to the still depth of the subject, we can find that crust is again divided into two layers. Crust is again divided into two layers. One will be calling as upper crust, second will be calling as lower crust. Again mantle will be divided into two layers. One will be calling as upper mantle, second will be calling as lower mantle. But for the core, we are calling it as outer core, and we are calling this as inner core. Due to some scientists, because of some scientists, they said that outer core is completely liquid. That is why S waves are not going into the outer core, right? That means what is our Earth is having? Earth is having solid, liquid, and a solid. That means the most center part of the Earth is solid, but the one layer above the center part of the Earth will be liquid. What is the center part? That will be called as outer core. Outer core completely consists of liquid. So now here how many layers we are having? We are having two layers in the crust. We are having two layers in the mantle, and we are having two layers in the core. Again, these layers will be having discontinuities. What are discontinuities? Here we will be having one discontinuity. Here we will be having one discontinuity. Here we will be having second discontinuity, and here we will be having third discontinuity. Right? That means we are dividing each layer into 6 different zones. That means how many discontinuities we will be having? We will be having each discontinuity in the each layer, right? Again, the discontinuity in the crust will be called as Conrad discontinuity. Discontinuity in the crust will be called as Conrad discontinuity, and discontinuity in the core will be called as Lehman discontinuity. Now we'll be discussing about we'll be discussing mantle. Before discussing the discontinuity of the mantle, we already spoke about something called as asthenosphere. What is asthenosphere? Asthenosphere is a liquid layer. Liquid layer means there is some layer of liquid for nearly 700 kilometers, because the length of mantle is nearly 2800 kilometers. The length of mantle is nearly 2800 kilometers. In the upper mantle, we are having a small layer which is nearly 700 kilometers, which is completely full of liquid. This layer will be called as This layer will be called as asthenosphere. That means again asthenosphere will be having two discontinuities. Here we will be having one discontinuity. Here we will be having other discontinuity. This will be called as Daham discontinuity, and this is called as repeated discontinuity. So how many discontinuities we are having? We are having, see, first one is Conrad. Conrad is between upper crust and lower crust. Second one is discontinuity between crust and mantle, that is Mohorovičić discontinuity. Again in the mantle we are having two discontinuities. One is Daham as well as repeating. Again between mantle and core we are having Gutenberg discontinuity. In the core we are having discontinuity that will be called as Lehman discontinuity. Total how many discontinuities? There are 6 discontinuities. If we write all the discontinuities in the top to bottom order, they will be like this. First one will be Conrad. Conrad is between upper crust and lower crust. Second will be Mohorovičić. Mohorovičić is between crust and mantle. Third will be Daham. Fourth will be repeating. Both are in the mantle and asthenosphere. Then fifth will be having Gutenberg. Gutenberg is between mantle and core. Last will be having Lehman. Lehman is between outer core and inner core. So this is the structure of that. So recently what was the question? Recently this was the question. In the exam called as Andhra Pradesh APPSC Group 1 exam. Group 1 exam is the highest exam of the state, right? See, in the highest exam of the state, what is the question they asked? They asked what is the layer between crust and the mantle. So answer is Mohorovičić. All these layers are once upon a time questioned in all the exams, right? And SSC is very particular about the layers of this, right? And everything is a question in SSC, right? Thank you.
Thanks for watching Rankers Hub. For more such videos, please do subscribe to our channel, do like our videos and share all our videos. Thank you so much.